Have you ever stopped to think about what really makes our modern world go round? I'm not just talking about the obvious stuff, like batteries or power plants. No, I'm talking about the silent, totally invisible intelligence that's managing every single watt of energy flowing around us. Today, we're going to dive deep into this hidden world. So think about this for a second. What's the one thing that connects a drone adjusting its flight path in a split second, an electric car charging up without destroying its battery, and our entire energy grid staying stable on a super windy day? Well, the answer is a field of engineering that is absolutely essential, but most of us never even see it. It's sophisticated power control. It's the art and the science of making electricity not just powerful, but smart, clean, and incredibly efficient. So in this explainer, we are going to pull back the curtain on this unseen engine. We're going to explore how engineers are wrestling with these massive challenges in energy waste and system intelligence, and this applies to everything from a tiny little drone to power grids that span entire continents. We'll kick things off with the fundamental quest for perfect efficiency. Then we'll get into the art of creating these intelligent, self-correcting systems. From there, we'll scale way up to see how this is all going to power tomorrow's green energy grid. And finally, we'll look ahead at the next great challenge on the horizon. All right, first up, the relentless quest for efficiency. In the world of electricity, every single tiny fraction of a percentage point of wasted energy really, really matters. And it turns out, engineers have two main villains they're constantly fighting. The first villain is something called a poor power factor. The best way to think of it is like the foam on a beer, right? You paid for a full pint, but a big chunk of that is just useless foam. A perfect power factor of 1 means you get all beer, no foam. Every bit of power is doing actual work. Anything less than 1 is just wasted energy. And then there's villain number 2, total harmonic distortion, or THD. This is basically electrical pollution. It's like having a bunch of static on a perfectly clear audio recording. This noise can actually damage sensitive electronics and, you guessed it, waste even more energy. So for THD, the lower, the better. So the mission for these engineers is pretty straightforward, right? Get that power factor as close to a perfect 1 as humanly possible, and at the same time, crush that electrical noise down to almost nothing. It's this constant battle for clean, efficient power with practically zero waste. And just look at how ridiculously close they can get. Using this advanced bit of kit called a totem pole power factor correction converter, researchers hit a power factor of 0.99984. I mean, that is just astonishingly close to perfect. That is the no foam beer we were just talking about. And get this, at the exact same time, that same system slashed the electrical noise, the THD, to just over 1.8%. This isn't just a tiny improvement, folks. It's a huge leap forward in delivering pure, high-quality power. This has a massive real-world impact. Just take an EV charger, for example. As you can see, without this kind of advanced control, you get lower efficiency and a lot of potentially damaging electrical noise. But once you apply these techniques, that charger becomes way more efficient and the power quality just skyrockets. But, hitting that kind of efficiency isn't just about better hardware. It actually requires something even more impressive: the art of intelligent control, where these systems can literally think and adapt all on their own. For years, control systems were pretty rigid. They just followed a strict set of rules, kind of like a basic script. But these newer methods, sometimes called fuzzy or adaptive controls, they are an absolute game changer. They're flexible. They don't just follow a script. They actually learn from what's happening and adjust their performance in real time. Here's a really simple way to think about it. A traditional controller is like one of those old, basic thermostats on the wall that just turns the heat on or off at one temperature. A fuzzy, adaptive controller, that's like a modern, smart climate system that learns your habits, checks the weather, and adjusts itself to be perfectly comfortable and super efficient. Let's take a sophisticated drone, a UAV. Its power control system is constantly working. It can sense a tiny anomaly in one of its engines, instantly analyze what's wrong, and then correct for it on the fly. All of this without the pilot even having a clue that anything happened. That is real-time intelligence at work. And it gets even smarter. These systems are now becoming predictive. By analyzing these minuscule fluctuations in a motor's electrical current, a control system can actually tell that a drive belt is losing tension. It can predict a failure before it happens, and then make adjustments to prevent it. It's incredible. Okay, so we've got efficiency and we've got intelligence. Now let's scale all of that way, way up.
How do these concepts help us solve one of the biggest challenges of our time, building a stable, green energy grid for the future?
Well, bringing massive wind farms into our grid is a huge puzzle. Wind is powerful, yeah, but it's totally unpredictable. A sudden gust of wind or a sudden drop can send these destabilizing shocks through the entire grid. So the challenge is, how do you smooth out all those fluctuations and keep the power quality high?
The solution is a really advanced piece of control engineering called an H-infinity, or H-onfinity, controller. The absolute best way to think of it is as a super-fast, intelligent shock absorber for the electrical grid. It sees the chaotic power surges from something like wind coming, and it instantly counteracts them, keeping the whole grid perfectly balanced. And let me be really clear about this. Without advanced controllers like these, a big, large-scale grid that depends on wind or solar would be incredibly unstable. This technology is literally the key that unlocks a reliable, green energy future. And the results are just dramatic. You can see here, without this advanced control, you get these huge, chaotic swings in the grid's voltage. But as soon as that HIOS controller is turned on, the line becomes smooth and stable. It is the difference between chaos and control. Wow. So we've journeyed all the way from the quest for pure efficiency to the art of intelligent control and right up to securing our planet's energy future. So what does it all mean? And what's next? I think the big takeaway is this. Our future isn't just about switching to electric power. It's about making that power smart. The real revolution is happening in these control systems that manage, clean, and direct all that energy with microscopic precision and predictive intelligence. And that leaves us with one final thought. As everything from our cars to our homes to our entire cities becomes part of this single, connected electrical ecosystem, the demands on these control systems are going to grow exponentially. So the question is, what will be the next frontier for this unseen engine that powers our entire world?